Hello! We're now going to look at how to create more complex actors and define the relationship between them. Up to now, we have created the avatar. He can move about, and the camera is fixed to him. These are fairly simple behaviors to set up. And we are now going to look at some more sophisticated behaviors as we add collectible coins and set up the avatar to throw shuriken. First of all, we'll make a category called Collectables. As you can see, this is a separate category from the avatar, and you'll see why I have created this category in a few minutes. Then we add the coin actor. Open it up and add the first animation frames. Now, the coin is not going to be moving, and it doesn't need orientation, so we can safely leave it as a dynamically rotating object, meaning we don't need to set up a 4-direction animation wheel or add more than a single sequence of animation. We'll simply call this animation default, because it's not an idle animation, it's not a running animation, it's just, you know, the one animation this actor runs. We'll then import the coin frames. Here they are. And we'll then arrange the frames in the correct order. In this case, you can identify the order of the frames by looking at the highlight. The first frame has a highlight at the bottom. We'll then drag in the one with highlight just under the middle, then the one with highlight just over the middle, and finally the frame with highlight at the top. We'll play to see how it looks. Well, that's still way too fast. We'll set up the frame delay slightly. Play, and it looks just fine. Reset the animation frame delay and show the collision geometry. Now, as you can see, this shape is slightly more complex than before. In this case, it's slightly more important that the collision geometry actually envelops the object properly. It doesn't need to be entirely accurate, but it means that this object should be collided with whenever the avatar is anywhere nearby it. Actually, I think I'm overdoing it a bit. This will probably be more than enough. We'll also slightly overshoot the outline of the actor to make sure the colliding with it feels snappy and instantaneous. We don't want the actor to appear to enter the coin before it is collected. We don't have to bother with the mass and the friction and the bounciness of the coins, that they're most likely going to be hanging in the air or simply standing somewhere completely mobile. Now, we've set up the animation, we've set up the collision geometry, now all we need to do is set up the logic. First and foremost, you will want to make a setup behavior. I usually make setup behaviors to distinguish the behavior that sets an actor's state when the game starts, as opposed to the behavior that runs or executes on every frame. There's a particular block for this called setup, which means that the following effects will only be executed on the first frame that an actor appears in the world. So in this case, we're going to switch off its gravity. Because we want the coins to be able to hang in air and generally stay where we put them in the levels, we will want to set actor's gravity to off. This doesn't have to be updated every frame, so we keep it in the setup sequence. Furthermore, we will want it to ignore the physics of the avatar. Now, there are two types of collisions in Oh My Game. There are physics collisions, and there are registered collisions. Physics collisions is what occurs when, for instance, if the ninja were to encounter a box that had a certain mass and was physicalized, with the gravity switched on and everything, you would notice that it would be pushed around by the ninja. Now, we don't want the coin to be pushed around. We simply want it to stay where it is and register that it's been hit. And once it's been hit, it vanishes and adds a number to the score. So, we search for ignore physics. Take this first logic block that appears in the list and drag it in. Now, this accepts a new type of variable. This is called an actor group. Actor groups are simply lists of either actors or actor categories, or both actors and actor categories, that will be treated as a single entity in a logic sequence. So, for instance, if you want your avatar to be able to collide with, to check collisions with enemies, you don't need to put in a behavior for each different type of enemy. Instead, simply make a behavior called enemy collision. Make a group that incorporates all the enemies you want the avatar to collide with, and add them. Every time you collide with an actor from that list, from that group, it will fire the logic that you have determined. We'll have a closer look at that later. Now, for now, we'll simply set up the collision group, including the ninja. We think that there's a chance that more actors than simply the coins will have an interest in ignoring the avatar, or doing something else with the avatar. So we'll click Variables, open Global Variables, and make a new global attribute category. We'll call it Ignore Groups. Or actually, to make it even clearer, we'll call it Physics Ignore Groups. Now, we'll add a group called Ignore Avatar. We'll simply put the entire avatar category in here, as we feel fairly safe presuming that the coins will not want to interact with anything that the avatar does later on, including his shuriken, or whatever other weapons we choose to give him. Add the attribute. Now click the actor group icon, select global attributes, and ignore avatar. The coin will now ignore any physical contact with the avatar. It will not get pushed around, it will never move from colliding with the avatar. Now, let's make it disappear and add a score when the avatar hits it. So we'll call this Ninja Collision. And here we say, collision, when this actor, as in the coin, is touching an actor of type avatar, it will be destroyed, first and foremost. It will vanish from the world. And then it will add a value, a number of points. You'll need to go to Variables and choose Add Number to Variable. Once again, we will want a global attribute, because several other actors, including our interface or other parts of the game, may want to inspect the score variable. So we'll make a new category again. You'll want to make a new global variable holding the amount of coins that the ninja has collected. Now, there's probably going to be more than one scoring system in this game, so we'll make a global attribute category called Score. We will add an attribute called Coins. Make sure that it's a number and that it's set to 0. and then we can expect the logic again. This block, and then we add the number block from the effects category. This will add a given number to a given variable. In this case, we want to add the number 1. You don't need to make a variable in order to provide values. You can simply input them into the block, like this. If you want to change it, you can click it again, enter number value, and say 60, for instance. But in this case, we want it to be 1. Now, here you determine which variable will receive the number. We'll click it, select Global Attributes, Scores, and Global Coins. This means that whenever a coin, this actor, is touching another actor of type avatar, this coin will be destroyed, and 1 will be added to the variable Global Coins. Now we're going to put some coins in the level and see if the ninja can successfully collect them. Let's see, we go to the level, wait until it's loaded. Select the actor layer, and notice that the coin has appeared. We'll simply drag the coin in here and place some around. You can use the grid to align actors, although they'd never snap. Now, we have a nice little collection of coins in the level, and we'll have a look at how the ninja interacts with them. Let's see. Oh. Ninja does indeed collect the coins. As you can see, he's not pushing them anywhere, he's simply colliding with them and removing them. Now, we haven't displayed the score display right now, but I can assure you that a value is being added to the coin attributes. Press back to editor and we'll try to implement some shurikens. Go back to the actors list, select the avatar actor category, and add the actor shuriken. Press create actor. Now, once again, the shuriken is a fairly simple object. We'll go into its animation and physics, add the default animation frame, and import a single frame. We'll set up its collision geometry, that's fine. We'll set its mass to be very low, and the other values won't really matter. That's all we need to do in here, and then we go back to behaviors and logic. Now, again, we need a setup behavior in order to set up the initial parameters of the actor. So we go back into timing and select the setup block, go to effects and type ignore physical contact with all other actors of a group. We're going to add the ignore avatar group because we don't want the shuriken to be able to collide with the ninja. However, we also really wanted to avoid the coins as well. We don't want the shurikens to be able to move the coins. So that means this ignore avatar group is not going to be enough. We go to variables, select the physics ignore group from the list. We could always modify the avatar group to include the collectables, but that would be confusing. So let's make a ignore everything actor group. Now in here, we'll simply add both avatar and collectables. This means that the shuriken is not going to collide with any other actor in the project. Of course, as you add more actor categories, you'll need to add more categories to the Ignore Everything actor group, but for now this will do. Also note that you only need to update the actor group in order to update the logic. So if you add further actor groups later, you simply need to add it to the Ignore Everything group, and this will be reflected in the logic above. We also want the shuriken to ignore gravity. If we don't ignore gravity, he will immediately be affected by gravity and pulled towards the ground. This means that the player will have to aim very carefully in order to hit anything, and we want to avoid that because this is a simple game. Now, set the actor's gravity to off. Now, these shuriken are never destroyed. They will simply linger in the world forever when thrown. They will hit walls, and they'll hit ground, and they'll even hit other actors, but nothing will happen. So we need to make sure that it gets destroyed when it hits something. So, we add a new behavior, calling it destroy actor, or destroy shuriken. It's even clearer. Now we need to resolve collisions between the shuriken and other actors as well as the level geometry. We can choose to resolve all collisions with actors through a single block, and we'll try to do that. Now, when this actor hits an actor of a group, it will destroy itself, much like the coin. However, we can't really use the Ignore Everything group, because then it might get destroyed on the very first frame it appears, because it's being thrown by the ninja, and as such is spawned near the ninja. If the shuriken then hits the ninja, it will be destroyed before it can travel anywhere. Also, since the Ignore Avatar and Ignore Everything groups are in the Physics Ignore groups, it will be very confusing for anyone else trying to read your code to suss out what you're thinking. So the solution is to go back into variables and make yet another global attribute category. We will call it collision groups. Now, we'll make a avatar collision group, including the avatar category, and we will make a collectable collision group, including all of our collectibles. Now, when this actor hits an actor in the group collectable collision group, it will be destroyed. This means that it will not be destroyed if it hits the actor, no, the ninja, or any other actors. We also want the shuriken to be destroyed if they hit geometry, if they hit the collision geometry of the level. So we'll choose the when this actor hits the static collision geometry, and once again select destroy this actor from the effects list. Now, this is all you really need for the shuriken. When it appears in the game world, it ignores physical contact with every other actor, meaning it will not push around the ninja, the coins, or anything else. It also ignores gravity, meaning it won't fall to the ground. If it hits an actor in the collectible collision group, which comprises the collectibles category, it will be destroyed. If it hits the collision geometry in the level, it will also be destroyed. Now it's time to add the logic allowing the avatar to actually throw the shuriken. Now select the avatar from the avatar category in the actors list, add a new behavior and call it throw shuriken. Go to causes, choose input and when the key is. This block allows you to give a key from the keyboard as input to perform an action. Now, we will select the K key, so this sits right next to the jump key, which is J, and when it is held, not held, pressed, or released, it will activate. We want this to happen when the button is pressed. Now we go to Effects and we search for the launch block. Now this allows an actor to be launched, an actor to launch other actors. You give the type of actor to be launched, in this case the shuriken. You set the direction in which to throw it, and you set the speed at which it will be thrown. Now remember, the speed at which an object moves is dependent on its mass. The shuriken had a very low mass of only 1, meaning we don't need to set a fairly high value. We'll simply insert 10 for the time being and see how that works out. Now, we will need to set a direction. Since our avatar can be moved in 2 directions, it will not suffice to simply use 1. No, we'll have to evaluate the direction in which the avatar, the ninja, is moving, and then make sure that the shuriken is thrown in the right direction. This means we'll need to use some more blocks. First and foremost, we'll make a new behavior to avoid confusing the throw shuriken logic. As you become more proficient at using Oh My Game, you will most likely want to collate different behaviors into one, but for the time being, we'll make it simple and keep them separated. We'll call it check angle. The purpose of this behavior will be to constantly monitor the direction in which the ninja is traveling. So, on every frame, we want to store the angle of the ninja. So, we drag in the store this actor's angle in attribute X block, and here we will need to establish a local attribute. Most other actors aren't going to be particularly interested in which direction the ninja is traveling, so we'll simply make it local. Select local attributes and create local attribute. Call it avatar angle and set it to 0. Add attributes. Now you'll need to press the number icon again and give it the avatar angle. This means that on every frame, the avatar's angle will be stored into the avatar angle attribute. Now, if you go back to the animation and physics editor, remember that 90 degrees is facing to the right, while 270 degrees is facing to the left. That means our throw shuriken logic, behavior, will need to inspect the angle of the ninja. That means we need to use the comparison blocks. So, okay, now this is the compare numbers block. It will evaluate 2 values, in this case 2 numbers, and execute the following logic if the comparison is valid. So we'll drag it in and place it under the key K is pressed, meaning that both of these causes will have to be evaluated and valid for the launch to happen. So, when the key K is pressed, and when the avatar angle equals 90 degrees, launch an actor of type shuriken from this actor in the direction 90 degrees, because that's rightwards, at speed 10. Now, we want to sort out the other direction as well. Now, we'll need to replicate this logic. Again, go to causes and search for when the key is pressed and drag it in. When the key K is pressed, and then look for the compare block. When local avatar angle equals 270, which is facing leftwards, go to Effects, type Launch, and drag in the Launch an Actor of Type block. Again, give the type as Shuriken, give it the direction of 270, and speed 10. Now, when we test the game, the avatar should be storing its angle to a variable, check the direction in which it's facing, and launch a shuriken in the right direction. Notice that he's launching the shurikens. He's not playing an animation to do it yet, but he's launching the shurikens. Now let's set up so that he also plays an animation directly after throwing the shuriken. Make a throw shuriken animation behavior. Go to causes and select the on every frame block, because we want the animation to play on every frame. Go back into effects and search for play animation. Drag it into the behavior, select play animation, throw animation, and set the restart to yes. If you set the restart to yes, it means that every time the animation is called, it will start playing the animation from the first frame. If you set the restart to no, you will resume playing the animation from the frame it was last stopped. We want the animation to start over every time the player throws shuriken, so we set it yes. We also want to stop the animation, so we have to inspect how long it is. Go back to the animation and physics panel, open the throw animation, select the direction, and count the number of frames. In this case, it's 5 frames with a frame delay of 1, meaning that it only lasts for 5 frames. Go back to behaviors and logic, open the throw shuriken animation, select causes, and drag in the every frame x frames logic block. Here you can set an effect to execute at a regular interval. We want the throw shuriken animation to be switched off every 5 frames after it has completed playing once. So we give it value 5, meaning every 5 frames, and then we deactivate the behavior that plays the animation. So you need to go into Effects, choose Behaviors, and switch off this actor's behavior. Press the open field and enter the name, Throw Shuriken Animation. Press Enter to commit. Now, this will play the shuriken animation, but we don't want it to play on every frame, because even though we have the movement set up here, we still need the animation to be played only when necessary. So, we deactivate the throw shuriken animation behavior, we go to throw shuriken, and we set it to play the shuriken animation only when the key is pressed. We do this by switching on the throw shuriken animation behavior every time the key is pressed. So, we switch on the throw shuriken animation. Make sure to add this block to both of the shuriken throwing logic sequences. So, we switch on the throw shuriken animation one more time. So, what happens now is that when the key K is pressed, we check which direction the avatar is facing in. We then launch a shuriken from the avatar in the given direction at the given speed. We also switch on the behavior controlling the throw shuriken animation. In the throw shuriken animation, which is deactivated, the throw animation is played on every frame and the behavior is switched off after the animation is completed, which takes 5 frames. Now let's test this. As you can see, the ninja throws the shuriken. As you can also see, his animation frames is slightly messed up, but we can fix that. That concludes the tutorial in making more advanced actor behaviors.